Good morning, students. Today class we will solve few problems on the topic capacitor and capacitance. Right. So take the first problem. In a parallel plate capacitor with air between the plates, each plate has an area 8 into 10 to the power of minus 3 meter square, and distance between plates is distance between plates is 2 millimeter. Calculate the capacitance. Calculate the capacitance of the capacitor if this capacitor is connected to a 50 volt supply. What is the charge on? What is the charge on each plate? What is the charge on each plate of the capacitor? Given epsilon naught is equals to 8.85 into 10 to the power of minus 12 farad per meter, right? So simple question, but ತುಂಬಾ ಸಲ repeat ಆಗಿದೆ question. Same method, right? So first note down the given, right? So ಏನೇನು ಕೊಟ್ಟಿದ್ದಾರೆ ನಮಗೆ? A parallel plate capacitor between the air medium between the plates. So each plate has an area that is 8 into 10 to the power of minus 3 meter. That means the given area A is equals to 8 into 10 to the power of minus 3 meter square. Next, and the distance between the plates they given 2 millimeter, right? So that is small d. So it is in 2 millimeters. So 2 into 10 to the power of minus 3 meter, right? So here we need to find the capacitance of the capacitor, and next if the capacitor is connected to 50 volt supply, so that means they given the potential, right? That is 50 volt, and also they given epsilon naught constant value 8.85 into 10 to the power of minus 12 farad per meter, right? So to find capacitance of a capacitor and charge on the each plate of the capacitor, right? So we know the formula for the capacitance of the capacitor. C is equals to epsilon naught A divided by D, right? So we know the standard formula. C is equals to K epsilon by D. So the given air between the plates, so hence K becomes 1, right? So now substitute the values. 8.85 into 10 to the power of minus 12 into area 8 into 10 to the power of minus 3. The distance between the plates 2 into 10 to the power of minus 3 meter. So here 10 to the power of minus 3, 10 to the power of minus 3 cancels. So 2 4s are 8. So C is equals to so 35.40 into 10 to the power of minus 12 farad. So this gives the capacitance of the capacitor, right? So next we need to find the charge on the capacitor. The formula C is equals to Q Q divided by V. So here we know the capacitance and then given the voltage, that is 50 volt. So from this we can find Q, right? So Q is equals to C into V. So 35.4 into 10 to the power of minus 12 into 50 volt, right? So we get so 177 into 10 to the power of minus 11, right? So this can be written 1.77 into 10 to the power of minus 9 coulomb. So 1.77 nano coulomb, right? So once they ask this, so this year in supplementary exam also they ask this type of question. So only the values are changing. So area of the plate they given 6 into 10 to the power of minus 3 meter square, and the distance between the plates they given 3 millimeter, and they given voltage 100 volt, right? So same question two times repeated. So ಮೊನ್ನೆ supplementary exam ಆಯ್ತಲ್ಲ, so ಅಲ್ಲಿ ಕೂಡ same question ನ ಕೇಳಿದ್ದಾರೆ, right? So just replace the values. A is equals to 6, B is equals to 3 millimeter, that is 3 into 10 to the power of minus 3. So V 100 volt, 3 into 10 to the power of minus 3. A is 6 into 10 to the power of minus 3. So D 3 into 10 to the power of minus 3, right? So here 3 ones are 3 2s are, right? So 17.70 into 10 to the power of minus 12 farad, right? So now substitute here. So C is 17.7. Here they have given voltage 100 volt. So it becomes 17.7 into 10 to the power of minus 10. So 1.77 into 10 to the power of minus 9 coulomb, right? So idu first method. So 3 to 4 times same method na exam al kelidare, right? So e question nearly 2 times they ask the same question, right? So move to the next one. So next question. The plates of a parallel plate capacitor have an area of 100 centimeter square each, 100 centimeter each, and are separated by 3 millimeter. The capacitor is charged. The capacitor is charged by connecting into 400 volt supply. So in the first one, calculate electrostatic potential energy. Calculate electrostatic potential energy stored in the capacitor. Next, B. If a dielectric of dielectric constant (2.5) is introduced between the plates of capacitor, between the plates of capacitor, then find the electrostatic energy stored and also changing the energy stored. Right. So this one is the second type, right? So here this question is based on the energy, right? So the given parallel plate capacitor have an area, they given the 100 centimeter square each, and these are separated by a distance 3 millimeter, right? So now the capacitor is connected to 400 volt supply. So here we need to find the electrostatic potential energy stored in capacitor. So this is the first case. Next, the same capacitor is inserted a dielectric medium in between the plates. So dielectric constant they given 2.5. So now after inserting the dielectric constant, again we need to find the energy stored 400 volt, right? So to find, so in the first case we need to find U, that is the energy stored in the capacitor, and in the second case we need to find the energy stored in the capacitor when dielectric constant they mentioned K is equals to 2.5, right? So next again we need to find the change in energy. So delta U is equals to U dash minus U, right? So we know the relation for the energy, right? So energy U is equals to half C V square, right? So we know V here, but we don't know C. So first we need to find the C. Again by using the formula C is equals to epsilon naught A divided by D, right? So epsilon naught value is a constant, that is 8.85 into 10 to the power of minus 12 into area 10 to the power of minus 2 divided by distance between the separation 3 into 10 to the power of minus 3, right? So here we get to the 6. Next 3 7 are 21. 2.75 into minus 12 minus 2, that is minus 14. Minus 14 plus 3, it becomes minus 11. So capacitance we get 2.75 into 10 to the power of minus 11 farad. Now substitute in this formula, right? So U is equals to half CV square, right? So 1 by 2. So C is 2.75 into 10 to the power of minus 11, and the given potential 400, right? So that is 400 square, right? So 2.75 into 10 to the power of minus 11 into 4 square 16 and 100 square we can write that one as 10 to the power of 4 divided by 2, right? So 2 8s are 16, right? So 8 5s are 40. Plus 4, 16. 16 plus 6, 22. So 22 into 10 to the power of minus 11 plus 4. That is minus 7 joules. So that is 2.2. We can write 2.2 into 10 to the power of minus 6 joules. So this one is the energy. So the first case, right? So next, second, when dielectric is inserted, right? So we know C by C naught, that is equals to K, right? C is what when dielectric is inserted, C naught is what initially, that is in the air medium, right? So here I will take C dash and C, right? So C dash is equals to K into C. So again U dash is equals to, so this is for the second case, half C dash V square, right? So 1 by 2, so C dash we have K into C V square, right? So this we can write K times of 1 by 2 CV square. So CV square is what? Here we get the values, right? So K is 2.5 into half CV square value is 2.2 into 10 to the power of minus 6, right? 25 into 22. So we get 5.5 into 10 to the power of minus 6 joules. So this is U dash. So this is for the second case when dielectric is inserted. So no need to once again substitute the value of C and T. So here we get the value of CV square. So that's the value is 2.2 into 10 to the power of minus 6. So directly substituting here and simplify, right? So next here we need to find the change in energy stored. Delta U is equals to U dash minus U, right? So U dash is 5.5 into 10 to the power of minus 6 minus 2.2 into 10 to the power of minus 6, right? So 3.3 into 10 to the power of minus 6 joules. So this is the change in energy. Any doubts? On to the next one. So next fourth one. So this is passed in 2019 in a circular parallel plate capacitor. in a circular parallel plate capacitor, radius of each plate is 5 centimeter, and they are separated by a distance of 2 millimeter. Calculate the capacitance and the energy stored when it is charged by connecting the battery 200 volt, right? So again, first method of problem it is, but here the given circular plate of a capacitor, the given radius, so and separated by distance 2 millimeter. So here also we are going to calculate the capacitance and energy stored, right? So the given radius, that is r, is equals to 5 centimeter, that is 5 into 10 to the power of minus 2 meter. So we need area, right? So the given circular plate, right? So area of a circular plate is pi r square, right? So pi is 3.14 into 5 into 10 to the power of minus 2 whole square, right? So next, separated by a distance d is equals to 2 millimeter, right? So that is 2 into 10 to the power of minus 3 meter. So we need to find capacitance of a capacitor and energy stored in a capacitor, right? So we know the formula, that is for the capacitance of a capacitor, C is equals to epsilon naught A by D. So again here they placed in an air medium, hence K value is 1. Substitute the value 8.85 into 10 to the power of minus 12 into 3.14 into 25 into 10 to the power of minus 4 divided by, so distance of separation is 2 into of minus 3 meter, right? So if we simplify this, we get capacitance C is equals to 34.8 into 10 to the power of minus 12 farad. So unit is very important. So unit baridaga 1 marks. U is equals to half CV square, right? So 1 by 2 into capacitance is 34.8 into 10 to the power of minus 12 into they applied the voltage, that is 200 volts. Here we have 200 volts, right? So that is 2 into 10 to the power of 2 whole square. So 200 we can write 10 to the power of 2. So here we get 1 by 2 into 34.8 into 10 to the power of minus 12 into 4 into 10 to the power of 4. So 2 to the 4, right? 69.6 into 10 to the power of minus 8 joules. So this is the energy which is stored in the parallel circular plate capacitor, right? So this is asked in 2019 in last year paper. So one more method. When two capacitors or connected in series or connected in series connected across 4 kilovolt line, 4 kilovolt line. The energy stored in the system, the energy stored in the system, energy stored in the system is 8 joules. Energy stored in the system is 8 joules. The same capacitor is connected in parallel, is connected in parallel across the same line, across the same line. The energy stored is 36 joules, 36 joules. Find the individual capacitances. So this is one more method, right? So here they given two capacitors which are connected in series. So first they connected two capacitors of two capacitances C1 and C2. So these two are connected in series across the voltage. So across the voltage 4 kilovolt, right? So now the energy stored in this combination is, that is energy stored is equals to 8 joules, right? So energy will taken U, that is in series, right? So now the same two capacitors which are connected in parallel across the same voltage, that is 4 kilovolt. So capacitance C1, C2, right? So now the energy stored in parallel, that is equals to 36 joules, right? So here we need to find the values of C1 and values of C2. That means capacitance of the individual capacitors, right? So they given two cases. So in the first case, the two capacitors are connected in series and apply the same voltage in both the cases, in series and also in the parallel, right? So energy stored is 8 joules and energy stored in parallel, that is 36 joules, right? So by using the energy relation, right? So we know energy relation U is equals to half CV square. Next to 4s are 8, right? Sorry, 4 into 10 to the power of 3 whole square, right? So again here 8 is equals to 1 by 2 C1 C2 divided by C1 plus C2 into, so 4 square is 16 into 10 to the power of 6, right? So here 8 2s are 16, so 2 get cancelled, right? So C1 C2, that is equals to C1 plus C2 into, so this goes to the RHS, means it becomes 10 to the power of minus 6, right? Calling this one as equation 1. So now the same formula is applying for the parallel, right? UP is equals to half CP V square, right? So UP, that is energy stored in parallel combination, 36, that is equals to half. So combination of two capacitors in parallel, CP is equals to C1 plus C2, right? So if I write here C1 plus C2 and the voltage is 4 into 10 to the power of 3 whole square, right? So now here 18 is 36, right? So 18, that is equals to C1 plus C2. So here 16 into 10 to the power of 6, right? So C1 plus C2, that is equals to 18 divided by 16 into 10 to the power of minus 6. So it is in denominator. If it goes to the numerator, it becomes minus 6, right? 2 9s are 18, 2, right? So 18 by 16. So it will not divide, right? So 36 is equals to 1 by 2 into C1 plus C2, 16 into 10 to the power of 6. So 2 8s are 16, right? So C1 plus C2 is equals to 36 by 8 into 10 to the power of minus 6, right? So here 4 2s are 8, 4 9s are 36. So 4.5. C1 plus C2, that is equals to 4.5 into 10 to the power of minus 6. So calling this one as second equation, right? So now substitute here. So C1 plus C2, we get the value of C1 plus C2 is 4.5 into 10 to the power of minus 6, right? So C1 C2 is equals to 4.5 into 10 to the power of minus 6 into 10 to the power of minus 6. So this becomes 4.5 into 10 to the power of minus 12. C1 C2 is equals to, so this one, third equation, right? So substituting the second equation in first equation. So substituting the value of C1 plus C2, that is 4.5 into 10 to the power of minus 6, here into 10 to the power of minus 6. So we get 4.5 into 10 to the power of minus 12, right? So by using the formula C1 minus C2 whole square, that is equals to C1 plus C2 whole square minus 4C1 C2. So this is basic algebraic expression. A minus b whole square, we can write this one as C1 plus C2 whole square minus 4C1 C2. So if we simplify this one, we get the same C1 minus C2 whole square, right? So here we know the value of C1 plus C2, that is 4.5 into 10 to the power of minus 6 whole square minus 4 into, and also we know the value of C1 C2, right? So 4.5 into 10 to the power of minus 12, right? So in these two, we have the common, that is 4.5 into 10 to the power of minus 12, right? So if we taken from these two, 4.5 into 10 to the power of minus 12 common, so here we get 4.5 minus 4, right? So that is 4.5 into 10 to the power of minus 12 into 0.5, right? So 0.5, we can write this one as 1 by 2. So here 2.25 into 10 to the power of minus 12. So calling this one C1 minus C2, this is whole square, right? So we need to remove the square root. So C1 minus C2, that is equals to, so 225, we can write this one as 2.25 can be written as 225 into 10 to the power of minus 14. So this is under root. Right? So C1 minus C2, that is equals to 15 into 10 to the power of minus 7. Right? So this can we write C1 minus C2, that is equals to 1.5 into 10 to the power of minus 6. Calling this one as equation 4. Right? So by solving equation 2 and 4, so here we have C1 plus C2, here we have C1 minus C2, right? So if we simplify those two equations, we get C1 and C2. So solving equation 2 and 4, right? So C1 plus C2, that is equals to 4.5 into 10 to the power of minus 6 C1 minus C2, that is equals to 1.5 into 10 to the power of minus 6. So if we add these two relations, so here C1, so C2 get cancelled. 2C1 is equals to 6 into 10 to the power of minus 6. So C1 is equals to 3 into 10 to the power of minus 6. So we get the value of C1. Now substitute C1 in any of these two equations, right? So if I substitute here C1, 3 into 10 to the power of minus 6 minus is equals to 1.5 into 10 to the power of minus 6. So from this we can write C2 is equals to 3 into 10 to the power of 6 minus 1.5 into 10 to the power of minus 6. So we get C2 is 1.5 into 10 to the power of minus 6 farad. So we get the values of C1 and C2, right? So C1 is 3 microfarad and C2 is 1.5. So this is the final answer. So this is one type of the problem. So once ask this problem, right? So very lengthy problem. So here we need to remind this formula. C1 minus C2 whole square, that is equals to C1 C2. Right? So by this we completed the chapter electrostatic, potential and capacitor. From tomorrow we start with current electricity. Right? Thank you.